Okay guys, I'm sorry that I can't make it in today. Last night, like right before I went to bed, I got kind of the stomach flu thing going on, so I didn't want to bring that to you at class and make your weekend extra special. So I made this little video because I thought you guys might need some help in finishing up today's activities. So this is basically just the lecture that I would have given to you in class. So the big idea for today is that we need to predict the products in chemical reactions. And so that third worksheet in your packet that you received, hopefully this information will help you, and it'll also help you complete your POGL packet today. So if you guys remember back to those notes that we took, I think it said chemical reaction types, and it's where we colored with those like little circles, like the red, the blue, the green, the yellow. So I'm just going to kind of quickly review this and show how that worksheet is going to help you predict the products. So the first reaction type we have is synthesis, and that's where we had, it was an individual element, so A plus B, a different element, combined together or synthesize compound AB here. So hopefully you're remembering that from your notes. So an example of how you can have that is if you have one element, two elements, they're just going to come together. So here in this equation, I have an element of magnesium, element of oxygen, and remember oxygen's diatomic, so you do have to include the little 2 subscript here. So what's going to happen is it's going to be Mg plus O. So just like it's A and B makes AB, so your product over here is going to be Mg and O. Now I know you're probably wondering to yourself, well, where's the other 2? Remember, when we make ionic compounds, we have to balance out the charges. And if we were to think about this, magnesium has a 2 plus charge, oxygen has a 2 minus charge. So again, I want to put my finger, we're ignoring this. And so the element or the compound that we'd be forming is magnesium oxide. So it's just 1 magnesium for 1 oxygen. And now here's where you actually have to worry about balancing the equation. So now I've got 2 oxygens on this side, so now I need to put a 2 here so I can have 2 oxygens over here, but that did just now give me 2 magnesiums, so now I'm going to need to put a 2 in the front over here. So hopefully with a synthesis reaction you're okay with this. It's an element plus another element combining together to make a compound. And so those will probably be some of the easier ones to predict. The only thing that's confusing is if you have this diatomic, the diatomic doesn't show up over here in the compound. You just do it like we normally do with those chemical formulas, those ionic bonds. Okay, so remember back to a decomposition reaction. We had a compound and it separated out into its elements A and B. So here's our compound separating out to its individual elements. So the way that we would make a prediction for this is, well, whatever your compound is, we're going to break it down into more simple compounds, or we're going to break it down into its individual elements. So let me go ahead and give you a couple of examples of that. So here's an example of a decomposition reaction. We have water and it drops and it decomposes into element hydrogen and element oxygen. Here's another example. We have our potassium chlorate here, and this one's going to break down into more simple compounds. So we've got potassium chloride here and oxygen. So the idea is you just kind of have to figure out how this is going to break down into the smaller pieces. So single replacement reactions are a little trickier because you don't know if this C is going to be replacing A or B over here. The way that you will find that out though, and so you can better make your prediction of your product, is you're going to look for this element, see what the charge is, and if it's positive it's going to replace A, and if it's a negative charge it's going to replace B. And so if it is, then in this case we can see over here that it must have been a negative charge particle because it replaced B. And remember, in an ionic compound, positive is written first, negative is written second. So you're going to predict that C, since you would predict that C, if it was negative, would replace B, but if it was positive, it would replace A. So in this case, our example is C. So let me give you a real equation. So let's make a prediction here in this reaction. So we have hydrochloric acid, so we've got H and Cl. So in this case, H is going to be positive, Cl is negative. And then we have fluorine over here. So what do you think fluorine is? Do you think that has a negative charge or a positive charge? Well, I hope you said it's a negative charge, so this H is going to displace this Cl here, this other negatively charged particle. So when we write the formula here, it's going to be the positive plus the negative charged particle plus chlorine is by itself. We can see some other ones though, so let me just pause and write the next equation. So if we look at this next equation here, we've got silver, which is our positive charge particle. We've got nitrate, which is our negative charge particle. So then let's look here at hydrogen. And hydrogen is positively charged, so hydrogen is going to replace the silver in this case. So our formula, our products that we're going to make, it's going to be HNO3 yields, I gotta do plus, not yields, plus sorry, it's 5:30 in the morning as I make this video. Help me out, guys. What are we going to have? What's our leftover thing here? Hopefully you're saying silver. Okay, so there's our product. So that's how we're making the predictions for silver for single replacement reactions. Okay, so in this video, or in this reaction here, double replacement, we had AB plus CD, and then if you remember back to the shall we dance partner, like the boys and girls just switch places, and that's all that's going on here. So A is going to be positive, B is going to be negative, C is going to be positive, D is going to be negative. And remember, A is not going to be attracted to C because they're both positively charged particles, but A will connect with D and form a bond, and then C will connect with B and form a bond. And so that's how we can see our products here. Okay, so in this example here, we can see that we have silver nitrate and potassium chloride again. And so the idea here is you want to think, okay, this is positive, so it's going to come and hook up with this negative particle here. This is positive, so it's going to come and hook up with this negative particle here. So when you just write your formulas, you have to take the charges into consideration. So silver has a charge of 1 plus, silver has a charge of 1 plus, chlorine has a charge of 1 minus. So this formula is pretty simple to write. So it's just AgCl, then we're going to take our potassium, which has a 1 plus charge, and our nitrate, which has a 1 minus charge. Again, a nice easy formula to balance. So this will be KNO3. So that's how you would get the products, predict the products for a double replacement. You're just switching places between the positive cations and the negative anions. Okay, so we've seen this term acid-base before, and I told you just to treat it just like a double replacement reaction. But sometimes if you notice, oh, you have an acid and then you have a base, the product is going to be kind of a curious thing. So again, positive, negative, positive, negative. So this positive is going to hook up with this negative over here, and this positive is going to hook up with this negative. So I'm actually going to do the inside ones first because I think that's going to make more sense. So it's going to be sodium chloride, because this has a 1 plus charge, 1 minus charge, easy formula to write. But then if you look over here, you have H plus OH. So what does this kind of write? Well, it's going to write like HOH, but hopefully you're noticing, oh, well, hey, that's the same as water right there. So the product of an acid-base reaction is always going to be a salt and water. And so you know it's an acid, remember, because their H is out front, and you know this is a base because it has the OH anion. Guys, I'm sorry this is, I'm not there today, and this is kind of a quick shorthand video. I couldn't find the stylus this morning. So I hope it helps. Try to do your best on your worksheets the best you can today. I'll answer your questions on Monday.